Right. Good morning, all of you. So my name is Sheikh Kalesha, lecturer in mathematics, Siddheshwara PU College, the team IIT and Medical Academy, Davanagere. So today we discuss the topic integrals. So this is very important concept in calculus and our board and competitive side also. This topic is very important, especially in board. So in this topic totally 22 marks covered. So totally in this topic 22 marks given from, especially only board for this topic, 22 marks given for all sections, means 1 mark questions, 2 marks questions, 3 marks and 5, 6. So all sections questions are covered from this topic. So that's why this is very important topic and weightage topic for board purpose. Okay, 22 marks given. So now we discuss integrals. So integrals are two types. Integrals are two types. First one, indefinite integrals. And second one, definite integrals. Okay, so integrals are two types. First one, indefinite integrals and definite integrals. Now let us discuss the first part, indefinite integrals. So what is indefinite integral? Simply we say that indefinite integral means inverse process of differentiation. Inverse process of differentiation or antiderivative. Okay, na? So indefinite integral means just we says that inverse process of differentiation or antiderivative. So what we learn in application of derivative in sixth topic, there if we learn the derivatives, so that derivatives inverse process is called the indefinite integrals. Now let us take some functions derivatives. So first we consider d by dx of x square. So already we know that derivatives in application of derivative, d by dx of x square is equal to 2x, and again d by dx of sin x is equal to cos x. Okay, next, so d by dx of x cube by 3, that is equal to x square value. Okay, na? So now let us consider three derivative functions derivatives. D by dx of x square is equal to x, d by dx of sin x is equal to cos x, d by dx of x cube by 3 is equal to x square. Now in these derivatives, in this equation, so this is particularly 2x. So 2x is called the derived function of x square, derived function of x square, and similarly cos x is called the derived function of sin x, x square is called the derived function of x cube by 3, x cube by 3, and here x square, then this x square is called the antiderivative. Antiderivative of x square, antiderivative of x square. X square is the antiderivative of 2x. 2x is the derived function of x square, and similarly sin x is the antiderivative of cos x. Cos x is the derived function of sin x. X cube by 3 is the antiderivative of x square, and x square is the derived function of x cube by 3. Okay, clear this one? Next, let us take another three derivative functions like that only. So d by dx of x square plus 3 is equal to 2x. d by dx of x square plus 3 is equal to 2x, and d by dx of sin x minus 7 is equal to cos x, and d by dx of x cube by 3 plus 70 is equal to x square. Okay, na? Now first three derivatives what we observing here, in this derivative of x square is equal to 2x, here 2x is the derived function of x square and x square is the antiderivative of 2x. So like that only here also same, 2x is the derived function of x square plus 3 and x square plus 3 is the antiderivative of 2x, antiderivative of 2x. Similarly here also cos x is the derived function of sin x minus 7 and sin x minus 7 is the antiderivative of cos x, and x square is the derived function of this value and x cube by 3 plus 70 is the antiderivative of x square, antiderivative of x square value. Okay. So now what we observing from these two here, first function derivative, derived function is 2x, here also derived function is 2x, but derived functions are same but antiderivatives are different. Here x square there, here x square plus 3, and similarly here cos x antiderivative sin x and cos x antiderivative sin x minus 7 and x square antiderivative x cube by 3 and x square antiderivative x cube by 3 plus 70. From these 6 examples what we concluded, finally we concluded antiderivatives of all functions or above functions, antiderivatives of the above functions are not unique, means any derived function if you taken, that antiderivative is not same, any derived function antiderivative is not same. So that's why finally what we concluded here, from these 6 examples we concluded first, any or antiderivative of above functions, antiderivative of the above functions are not unique, okay na? So from these 6 examples what we observing, derived function is same but antiderivative of that function is different, antiderivative of that function is not unique or not same, okay na? So first 3 derivative functions there, no, generally if you have one function here, d by dx of f of x is equal to, d by dx of f of x is equal to f of x, and next 6 derivative functions there, no, by using that one what we have done here, next 3, d by dx of f of x plus c is equal to f of x value. Now first 3 derivative functions if you have done this general form, d by dx of x is equal to f of x, here f of x is called antiderivative of small f of x. Small f of x is called the derived function of capital F of x, and similarly from the next 3 examples derived functions what we concluded, small f of x is the derived function of f of x plus c and f of x plus c is the antiderivative of f of x, okay na? Here see here only x square sin x x cube plus 3, any addition value not there, but if you add some constant, so that's why I consider here that constant place if you have done c value, here c belongs to real number, c belongs to r, any real number if we consider, so that's why particularly whenever if you add antiderivative with any constant, then that derivative, antiderivative is called the family of antiderivative. This is only called antiderivative, but here if we add that function constant value, then at the time that functions are said to be, that antiderivative are said to be family of antiderivatives, So why if you add c means already explained here, every function must and should be have the some constant value, so that's why that constant value place if you add the c value, whenever if you add c, that is represent the family of antiderivatives, okay na? Now we define what is integration and what is antiderivative. What is integration and what is a antiderivative? So right here see integration or anti-differentiation integration or anti-differentiation. So here definition or there just we observing the process. So let us take in one derived function, means if you are applying the derivative of the given function. Now here what we written here, suppose x square is equal to 2x. So whenever integration or anti-differentiation, how do we define means in the derived function. Already I discussed, already I explained no more. So here 2x value is called the derived function of x square, and x square is called the anti-derivative of the derived function. So whenever in this case if you want to find out original function, then we are applying the integral on the derived function. So that's why I now take integral 2x dx is equal to 2 into integral x dx. This formula integral x dx, later we discuss that formula, just we remember this one, integral x dx formula, just what we written means x square by 2 plus c value, x square by 2 plus c. Now I substituted that formula here, 2 into x square plus 2 plus c. Now here 2 cancellation, then if you get the value x square plus c. But your this is the original equation, this is the original function Asima. Here original function is x square, but here original function is x square plus c. So in c, why you add c means here c is equal to 0, c is equal to 0. Now this function we converted x square plus 0, then automatically if we get the value x square plus 0, so c we consider 0 value. Now we are applying this process is said to be integration or anti-differentiation. And another example also if we consider same such type of one example, if we take here d by dx of x square plus 3, here only x square plus 3, that is equal to 2x. Now in this example also if we want to find out original function or integration, then we take the value integral of 2x dx is equal to what we done here, 2 into integral x dx. So already explained no in this formula integral x dx, later we discuss that one, that formula directly what we have substituted here, x square by 2 plus c. Now 2 cancellation, here x square plus c. Now this is original function x square plus 3, but here original function what, x square plus 3. So these two are coincide means in c place how much we consider, c is equal to 3. So that's why this is the process, this is the original function of the given. Here also x square plus c, but c value here 0, here c value is equal to 3 value. Now we are applying this process for every question in that topic. So this process is said to be integration or anti-differentiation. Okay na, integration or anti-differentiation of the given concept. Right, next. Now if we take one symbol, you introduce one symbol that one, so that symbol how to read. So integral of f of x dx. So in this throughout topic, if you read this symbol integral f of x dx, actually this is the anti-differentiation. But in this topic, throughout topic, if you read this symbol indefinite integral of f of x with respect to x value. So throughout this topic, if you read, actually this is the anti-differentiation, but anti-differentiation, how to if you read means indefinite integral of f of x with respect to x. Then if you run this integral f of x dx value. Now if you run the general form of indefinite integral, general form of indefinite integrals, general form of indefinite integrals, general form of indefinite integral. Just we remember this one, integral f of x dx is equal to, if we get the value f of x plus c, f of x plus c. So this is the general form of indefinite integral. So why we add c? Already I told you, why you add c means sometimes that constant value, original function if you want means in that original function, constant value there means that constant value sometimes eliminated. If you want that constant value, then if you add the c value, here c belongs to R. Here what ma? C belongs to R. Here if we define some conditions, here f of x is, here f of x is integrand. F of x is what ma? Integrand. Next, x is variable of integration. Variable of integration. Next, c is, if you add that c is arbitrary constant. Okay na? So in that general form of a indefinite integral, integral f of x dx is equal to f of x plus c. In that integral, this f of x, small f of x is called the integrand, and x variable, which variable we consider, that variable is said to be integration, variable of integration, and c constant, if you add a constant, that constant is called the arbitrary constant. When we finish that integration on the function, then after conclusion, final result must and should be if you add c value. Otherwise, if it doesn't add this c, that calculation totally wrong. That is not an integration. Okay, right? That point we remember, ma. So this is the general form of the integration value. Now we discuss the some standard formulas. Already if we learn formulas in derivative, like that only, here some standard formulas there in integration. Now that formulas if you remember, then easily if you solve the problems. Otherwise calculation oriented, that is the difficult only. So just I compare to the derivative and integration formulas. Suppose if you take one derivative, d by dx of x power n plus 1 by n plus 1 is equal to how much? X power n. If you know that this one, how do we get derivative of this value? X power n formula, n plus 1 into x power n plus 1 minus 1. Then n plus 1 automatically cancellation. Then x power n plus 1 minus 1, x power n value. So previously we discussed d by dx of any function derivative is equal to another function. In that relation, x power n is called the derived function. X power n is called the derived function. And x power n plus 1 by n plus 1 is called the antiderivative of x power n. Antiderivative of x power n. Now I want to find out this original function. Then how to find it? Already explained that one. Integration or antiderivative process. Now just we consider integral of this one. So integration formula from the derivative. What we done here? Integral of x power n dx is equal to integral of x power n dx is equal to. So this derived function integration if you want. This derived function integration antiderivative what here? X power n plus 1 by n plus 1. So that's why what we done, integral x power n dx is equal to x power n plus 1 by n plus 1 plus c. So why you add sir? Here c means already I told. Here constant 0 means c is equal 0. Here constant anything there. Then c, if we take that number, which number there, that number we consider instead of that place. Okay. Similarly, another differentiation if you take, suppose if we take here d by dx of x. D by dx of x is equal to 1 value. Now integration formula what we consider here? Integral of 1 dx is equal to x plus c value. And the third one, d by dx of sin x. So d by dx of sin x is equal to cos x. Now what is the formula of integral of this cos x dx is equal to sin x dx, sin x plus c value, sin x plus c, cos x integration sin x. Okay, next fourth one, d by dx of cos x. Generally what we have done here, cos x derivative minus sin x. So like that only, here if we consider this value, integral of sin x, if you want to write down, that value is equal to minus cos x plus c value. Cos x plus c. So this is the standard formulas of integration related with the derivatives. Okay now. So already we discussed now, these are the derived function. We applying the derived function on integration, then automatically if we get the value, what we get mother? That indefinite antiderivative of the function. So integral of x power n dx is equal to x power n plus 1 by n plus 1 plus c. Integral 1 dx is equal to x plus c. Integral cos x dx is equal to sin x plus c. Integral sin x dx is equal to minus cos x plus c. So similarly, and another formulas also there must similarly, if you find out remaining formulas, but these formulas are directly written here, sima. So fifth formula, integral of secant square x dx. Integral of secant square x dx is equal to tan x plus c. Next, sixth formula, integral of cosecant square x dx is equal to minus cot x plus c. Seventh one, integral of secant x into tan x dx is equal to secant x plus c value, secant x plus c. And eighth one, integral cosecant x into cot x dx is equal to minus cosecant x plus c value, minus cosecant x plus c. And next one ma, so tan, cot, secant, cosecant later. Next exercise we discuss that formulas with the proof, but these are the standard formulas. Next, inverse, integral 1 by root of 1 minus x square dx is equal to sin inverse x plus c. And 10th one, integral 1 by square root of 1 minus x square dx is equal to minus cos inverse x plus c, minus cos inverse x plus c. Okay na, right? Here sima, x power n formula, one formula cos x sin x, like that only secant square, cosecant square, secant x into tan x, cosecant x into cot x, minus cosecant, and inverse, I know sin inverse x, integral 1 by root of 1 minus x square, integral 1 by root of 1 minus x square dx. So totally what we observing here, these are the inverse process of the differentiation, and the remaining formulas there here. And next, these formulas extension, 11th one, 11th formula, integral 1 by 1 plus x square dx is equal to tan inverse x plus c. And 12th one, integral 1 by 1 plus x square dx is equal to minus cot inverse x plus c value. Next, 13th one, integral 1 by x into root of x square minus 1 dx is equal to secant inverse x plus c. And 14th one, integral 1 by x into square root of x square minus 1 dx is equal to minus cosecant inverse x plus c. Okay, next, 15th one, integral e power x dx is equal to e power x plus c, e power x plus c. So another formula, next standard formulas, sixteenth, integral 1 by x dx is equal to log of mod x plus c. And 17th one, integral a power x dx is equal to a power x by log a plus c value. Okay na? So these 17 formulas are the standard formulas in integration. If you remember these formulas properly, then if you solve the all questions in that topic, indefinite integral or definite integral also, we are applying the same formulas. Okay na? Next, further one, 4 formulas there, tan, secant, cosecant, and cot. Next we discuss after finishing of first exercise, we discuss that remaining formulas. So these are the standard formulas in indefinite integrals. Okay na? Next, here indefinite integral, some properties there ma. Properties of indefinite integrals. Already I told you that a derivative, so differentiation is the inverse process. Inverse process, integration means what? Inverse process of differentiation. So properties of indefinite integral. properties of indefinite integrals. Properties of indefinite integrals. So first one, the process of differentiation, and integration, the process of differentiation and integration or inverse each other, or inverse each other. So the process of differentiation and integration both are what? Inverse process. Means how to write means, so whenever if you run d by dx of integral of f of x dx, d by dx of integral of f of x dx, then that function given f of x only given. Now integral of f dash of x dx is equal to integral of f dash of x dx is equal to f of x plus c given, f of x plus c. Here first integration after differentiation. So after differentiation any constant value also become as a 0. So that's why if I direct function f of x value, integral of f dash of x dx is equal to f of x plus c. Why? Means first we are applying the derivative, after then we are applying the constant. If you want to take one example, otherwise if you want to take one example, f of x is equal to x square. Here if we take the value f of x is equal to x square, then what would happen here? D by dx of integral of x square dx, integral of x square dx. Now just I revised one formula, integral of x power n dx is equal to what? X power n plus 1 by n plus 1. Means whenever x power n formula there, means if you increasing the power 1 value, in differentiation if you decreasing, in increasing integration means first letter I there, means what? Increasing this topic totally if increasing the power. So differentiation decreasing the power. Okay, so like that if you remember, just so d by dx of integral of x square dx, first integration what would have done here? X cube by 3 value, x cube by 3 value. Okay na? So integration of this value x cube by 3. After then if you write on the value d by dx of what would have done here? D by dx of this value x cube by 3, x cube by 3, or after integration if you add the value c, d by dx of x cube by 3 plus c. After we applying the derivative, what put on here? 3 into x square by 3 plus 0. Correct? X cube derivative 3x square by 3. 3 cancellation, constant value 0. That is equal to, again if you get the value x square. Now f of x value, d by dx of f of x, integral of x square dx is equal to, again we get the value what here? F of x value. That is the first condition. Okay. Similarly we comparing here x square integral derivative value 2x integration what we done? 2 into x integration, power increasing, x square by 2 cancellation, again we get the value c value. Okay, then if you add that c means 0 value. So that is the first property. So first property what? The process of differentiation and integrations are inverse of each other, inverse of each other. Inverse of each other. So next one so any two integral values if you taken, integral of f of x plus g of x into dx is equal to, so addition or subtraction, no problem, addition or subtraction if you want to find out this integral, then we split that integral for every term. Integral of f of x dx plus integral of g of x dx value, like that more numbers also there, more terms also there. If you split that, in similarly derivative also if you u plus b formula, like that only f of x plus g of x, if you split that integration for the first function and second function, and the third one given so integral of k into f of x dx is equal to, so separate the constant terms, integral if you are applying the f of x into dx, here k belongs to r, k is any real number, so like that only if you take one infinite number of functions, means integral of first k1 f1 of x plus k2 f2 of x plus k3 f3 of x plus and so on kn fn of x into dx there. Now how to find out this all terms integration? Then we split that, means separated that every term with integration sign. Then what we done here? K1 integral of f1 of x into dx plus k2 into integral of f2 of x dx plus and so on. Then finally what we done here? Kn integral of fn of x dx values. Okay na? So these are the properties. So another property also there ma, if we take two indefinite integrals with the same derivative, if we take two indefinite integrals with the same derivative, that same derivative leads to family of curves, same family of curves. That property is not required. Just if you revise that property, if you take any two indefinite integrals with the same derivative, that leads to family of curves. So family of curves means what's that means? That one concept there, geometrical interpretation. So in that geometrical interpretation we discussed that one. Just they given like that, if you write on any one formula, means already explained no ma, indefinite integral standard general formula, integral f of x dx is equal to f of x plus c. Now if we represent this equation, this statement is said to be family of integrals, family of curves or family of integrals. Why means if you give the different value of in c place, different values of c place, then that integration given different integrals given. So many members are there in that integral. So that's why that is called the family of curves or family of integrals, family of curves and family of integrals. So these four properties if you remember. And another property, that is two indefinite integrals, if you take the same derivative on both sides, that leads to same family of curves. So this type of form, if this leads to this type of form. So these are the properties and formulas and concept of indefinite integrals. So this is the total concept about indefinite integrals. In that concept, next parts there, different type of parts there. So this is the major explanation about indefinite integrals. Okay na? Now let us start the exercise questions ma. If you solve the exercise questions. 7.1 ma. Exercise 7.1, he given Sima first question, find an antiderivative or integral, find an antiderivative or integral of the following functions by the method of inspection, by the method of infection. Here what given ma, find an antiderivative or integral of the following function by the method of inspection, by the method of inspection. Right, first question Sima here, sin 2x given. Sin 2x. Now generally if you find out antiderivative means integral, but he given by the inspection method of inspection. So that's why, so this type of question first we find out, we know that integral of sin 2x, integral of sin 2x dx. Already I explained that standard formulas, integral of sin x dx is equal to how much? Integral of sin x dx is equal to minus cos x plus c, minus cos x plus c. So this is the formula. Integral sin x dx is equal to minus cos x plus c. But how much there in x place 2x there? Here also same right. So then what we are here? Minus cos 2x, minus cos 2x by 2 plus c. After integration must and should be add the value c. But in generally derivatives what we done? After sin 2x derivative what? Cos 2x into 2. In derivatives if you done the x multiple into, but in integration if you done that multiple in denominator. That point we remember. So why you write means that is the substitution method there. So then we learn that concept also. Whenever if you completed integration, any multiples there, that multiples also if you do the derivative and we write the derivative in denominator. Now this is the general integration, but what we find out by inspection method given means if we take this value, so d by dx of minus 1 by 2 cos 2x, d by dx of minus 1 by 2 cos 2x. Now if we find out the derivative of this function, so minus 1 by 2 as it is, if you run next what we find out here, d by dx of cos 2x value, then that is equal to minus 1 by 2. This value how much ma? Minus sin 2x. This is the derivative, not integration, derivative into 2 value. So 2 cancellation, minus into minus plus how much this value? Sin 2x Already starting I explained, no, any function derivative is equal to another function given. That function is said to be derived function, and this is called antiderivative of the derived function. So now what we require here, this function derived, if antiderivative if you want. So that's why finally what we written here, antiderivative of sin 2x is minus 1 by 2 into cos 2x, minus 1 by 2 into cos 2x, okay na. So right here what we find out, actually antiderivative of this function, simply given find the antiderivative of this function, just we write on this one enough, but by given inspection method given. So that's why sin 2x actually integration if you write on like this, if we take this value only, then again we are applying the derivative, then if we get one function, already we know that this relation, any function derivative is equal to another function, that another function is said to be derived function of the given function, and this is called the antiderivative of this function. Now finally what we are done, antiderivative of sin 2x is this function. But so here why you add such c value, how much c value in this case, any constant not there. So that's why if you are here c is equal to 0. Here what we consider, c is equal to 0. Here c is equal to 0. Then anything problem not there. Then if you find out, this is the process of antiderivative. If you find out antiderivative by the inspection method, if you run this one, okay na? Right. Next question, same. Similarly, if you find out the cos 2x given, second question given ma, cos 3x given. So cos 3x. Then first we know that integral. We know that integral of cos 3x dx. First standard formula what ma? Integral of cos x dx is equal to here sin x. Sin x. So that's why what we written here, sin 3x by 3 plus c. So why you written by 3? Already told them in derivatives if you written multiple, but in integration must and should be written that x multiple how much there, that value in denominator, that value in denominator, okay na. Now if you written sin 3x by 3 plus c value, here again we consider here c is equal to 0. Now inspection method means what we written here, d by dx of this value 1 by 3 into sin 3x is equal to 1 by 3 into d by dx of sin 3x, sin 3x derivative 1 by 3 into cos 3x into 3 value. Now 3 cancellation, finally how much there here, cos 3x. Now this is the derived function and this is the antiderivative function of this one. So first finally what we run here, antiderivative of cos 3x, antiderivative of cos 3x is 1 by 3 into sin 3x value, okay na. So this is the another question for antiderivative by using the inspection method, and next one ma, e power x given. Next one what given ma, here e power x value given. Third question ma, e power 2x, and the fourth question ax plus b whole square, and the fifth question sin 2x minus 4 into e power 3x, e power 3x. Now if you want to find out antiderivative of by inspection method and the previous method, what I explained the previous two questions, the same method. So third question is given here e power 2x. Now we know that integral of e power 2x dx is equal to generally e power x by x multiple plus c. Here c is equal to 0. Then what we written here, d by dx of e power 2x by 2 is equal to, again if you written here e power, so 1 by 2 d by dx of e power 2x, that is equal to 1 by 2 into e power 2x into 2. So 2 cancellation. Again if you get the value 2 e power 2x. Now e power 2x antiderivative if you want means what we run here, antiderivative of e power 2x is e power 2x by 2, e power 2x by 2 value. Okay. Next, fourth question. Next, fourth question, ax plus b whole square value. So fourth one, ax plus b whole square. Similar process, first we find out the integral. We know that integral of ax plus b whole square dx is equal to 2 into, integral of ax plus b whole square means what we done here, ax plus b whole cube by 3. So why you done power 3? Here this is the integration, integral x power n formula, integral x power n dx is equal to x power n plus 1 by n plus 1. So 2 plus 1, 3 by 2 plus 1, 3. And again derivative of this function, ax plus b derivative, ax derivative a, b derivative 0. So that's why into a plus c. Here c is equal to 0. Here c is equal to 0. Now if we take the derivative, d by dx of this value, ax plus b whole cube divides 3a is equal to 1 by 3a into d by dx of ax plus b whole cube, d by dx of ax plus b whole cube. Then what we done here, 1 by 3a into this value, 3 into ax plus b whole square into a value. Now a value, 3 value, 3a value cancellation. Then finally if we get the value, ax plus b whole square, ax plus b whole square. Now this antiderivative is this one, ax plus b whole cube by 3a is the antiderivative of ax plus b whole square value. Okay na? Right, last question in that model, antiderivative of the questions, last one, fifth one, what given here, sin 2x minus 4 into e power 3x. So here fifth question given here, fifth one, integral sin 2x minus 4 into e power 3x dx. Already I explained some properties. In that property, sum or subtraction, any two terms there, if you split the integration for two terms, then what would on this value is equal to integral sin 2x dx minus 4 into integral e power 3x dx value. Now what is the integration of 2x, sin 2x? So sin integration cos minus cos 2x by 2. Here also if you add the c value, here also if you add the c, but commonly if you add one constant only, in this constant if you get c1, in this constant if you get c1, so finally c1 plus c2 is equal to c only. So that's why commonly if you add one constant value, so that's why what we done here, minus 4 into e power 3x by 3 plus c. Otherwise if you want to write here c1, if you want to write here c2, next step what we done, minus cos 2x by 2 minus 4 e power 3x by 3 plus c1 plus c2 is equal to c value. Okay, so instead of the 2c, if you take only one c, enough. Right, this is the first integration of the given. Now if you find out the derivative of this value, so d by dx of minus 1 by 2 cos 2x minus 4 by 3 e power 3x. Now this derivative what we have done, cos derivative minus sin. So that's why if you have done first constant 1 by 2 and this constant derivative minus 2x into 2 value, minus sin 2x into 2, next minus 4 by 3 e power 3x into 3. Here same 2 cancellation, minus into minus plus. Then what we on this value, sin 2x minus 4, 3 cancellation, e power 3x. This is the given function. This function antiderivative. Now this is the derived function of this function. Now this is the antiderivative. Then finally what we on here, antiderivative of sin 2x minus 4 into e power 3x is minus 1 by 2 cos 2x minus 4 by 3 e power 3x. So this is the antiderivative of the given function. So this is the one type of problems, one method. So first Roman he given 5 questions given. In that 5 questions what we find out antiderivative of the given questions by using the inspection method, then we applying this process. Okay na? Just he given find the antiderivative of this one means starting step only enough, integration enough. Now in this exercise, first exercise 1 mark questions important, compulsory 1 mark question given for board. So now let us discuss that remaining questions in exercise, first exercise. These questions are very important for 1 mark question. So here given Sima, find the following integrals in exercise, means find the following integrals in the following. In the following, if you find out the integral values. So first, 6th one given, what given Sima here, 6th question given, already 5 we completed nama, 6th one given integral 4 into e power 3x plus 1 into dx value. Now if you want to find out this integral, so how to write on this integral, that is equal to integral 4 into e power 3x dx plus integral 1 into dx. Just now recall that standard formulas. What formulas if you learn that formulas? So that is equal to 4 into integral of e power x, but what I told me here, except e power x, any multiple of x, that multiple if written in denominator, plus integral 1 dx is equal to x plus c. So this is the final answer for 1 mark question, 4 into e power 3x by 3 plus x plus c value. Next, 7th one. So integral x square into 1 minus 1 by x square into dx. So first we multiplying with x square or directly. So then what we done here, integral x square into 1, x square cancellation, minus 1 into dx. Now if you write on integration, so integral of x square dx, x power n formula, integral of x power n plus 1 by x plus 1. So that's why x cube by 3 minus integral of 1 dx, just now only written that formula, integral of 1 dx x plus c. After integration must and should be add the constant value, otherwise if it doesn't add this constant, 0 marks given for 1 mark question. Other 2 marks, 3 marks given means 1 marks, if you lost 1 marks. So must and should be add the constant value. Next, C, 8th one. So 8th one what given Sima here, integral of ax square plus bx plus c into dx given. Now if we applying the integration, 3 terms there, every term integration we applying, that is equal to first constant value there. So a into integral x square dx plus b into integral x dx plus c into integral dx value. Now already I told every integration completion if you write on constant, but here commonly if you write on one constant value, so that's why what we write on here, this value a into x cube by 3 plus b into x square by 2 plus this value constant cx plus c value, cx plus c. Okay na? So this is the derivative of the another question. So 9th one, integral, so 2x square plus e power x, 2 into x square plus e power x dx, that is equal to 2 into integral x square dx plus integral e power x dx. Then finally what we done here, 2 into x cube by 3 plus e power x plus c value. Here 10th question given, integral root x minus 1 by root x whole square dx. Integral root x minus 1 by root x whole square dx. Whenever whole square given, then we applying x power n formula, then difficult that one. So if we expand this one first, a minus b whole square formula, integral of first a square value x minus plus b square 1 by x minus 2ab 2 into root x into 1 by root x into dx. Correct this one? a minus b whole square, a square plus b square minus 2ab. A square b square means already root there, root square cancellation, and again root square cancellation, root x cancellation. Then finally integral of x plus 1 by x minus 2 into dx. Now we are applying the integration, x integration x square by 2 plus 1 by x integration what log of mod x minus 2x plus c value. Okay na? So first a square plus b square minus 2ab. After then we separate the cancellation, x derivative x square by 2. So 1 by x log of mod x minus 2x plus c value. So this is the 10th question and important, and previous question also the 10th one. Next 11th one integral x cube plus 5x square minus 4 by x square dx value, x square dx value. Now how to simplifying this integration? So here denominator and numerator given. So that's why if you separate the every term with the denominator, so that's why what we are done here, integral this value x cube by x square plus and again 5x square by x square minus 4 by x square into dx value, that is equal to integral x cube by x value, x square 5 value minus this value of 4 into x power minus 2 into dx value. Okay na? So now we separate the x square value for x cube plus 5x square minus 4 by x square. Now separate the these terms. Now we are applying the integration on these terms. That is equal to integral x dx, how much value? X square by 2 plus integral constant, this value 5x minus 4 into x power minus 2 given. X power minus 2 means x power minus 2 plus 1 by plus 2 minus 1. So then what we done here? X power minus 2 plus 1 minus 2 plus 1 plus c. After integration, immediately if you add the constant value, then that is equal to what we done here, x square by 2 plus this value 5x. Here minus 2 plus 1 minus, minus become as a plus, and again 4 as this 4 there by x power minus 2 plus 1 minus 1. X power minus 1 means by x plus c. So this is the derivative of the given function. Next 11th one, 12th one Sima. Okay na? Right, 12th one Sima. So 12th one what given here, integral x cube plus 3x plus 4 by root x into dx, root x into dx. Now previous question also same, 5th question what, 11th question what given, x cube plus x square plus 4 by x square given, but in this question what given, root x. Here also same process ma. First we separate the integral x cube by root x plus 3x by root x plus 4 by root x into dx. Okay na? So next step what we done here, that is equal to integral of, if you done here, x cube into x power minus 1 by 2. So why you done here x power minus 1 by 2? So this root, if you eliminate root, this is the value of x power 1 by 2. If you take on to the numerator, x power minus 1 by 2 plus similarly 3x into x power minus 1 by 2 plus 4 into x power minus 1 by 2 into dx. So this is only simplification. After then we applying the integration. So integral of, then see here, power 3 minus 1 by 2, 3 minus 1 by 2, 6 minus 1, 5 by 2. So x power 5 by 2 plus, again this value, here plus 1 minus 1 by 2. So 1 by 2, 3 into x power 1 by 2, correct? 1 minus 1 by 2, 2 minus 1, 1 by 2 plus 4. Here directly we are applying the integration for this one, 4 into x power minus 1 by 2 into dx. Now we are applying the integration. So x power 5 by 2 integration, how much? If you add plus 1, 5 by 2 plus 1, 7 by 2, x power 7 by 2 divides 7 by 2 plus 3 into, so plus 1, 3 by 2, 1 by 2 plus 1, 3 by 2, x power 3 by 2 divides 3 by 2 plus, here minus there. So then what would have done here? 4 into x power minus 1 by 2 plus 1, 1 by 2, x power 1 by 2 by 1 by 2, okay, plus c value. Next finally what would have done this conclusion? So finally if you run this value 2 by 7, 2 by 7 x power 7 by 2 plus this value 3 cancellation 2 into x power 3 by 2, okay. Next 4, this reverse if you taken means reciprocal 8, 4 2s are 8, 8 into x power 1 by 2 or root x plus c value. So that is the solution, okay na. So once again listen here, so this value root given, so root given means first if you separate the every term with the root x, after then if you eliminate that root x how to run x power minus 1 by 2, x power minus 1 by 2, x power, after then simplification, here 3 minus 1 by 2, powers are same variables, multiplication means if you add the powers 3 minus 1 by 2, 6, 5 by 2, and similarly 1 minus 1 by 2, 1 by 2 and minus 1 by 2, then we are applying the integration formulas, x power n formula, and if you add 1 and the denominator also, same if you add 1, denominator also, if you add 1, denominator also, minus 1 by 2 plus 1 plus 1 by. So then if you take the reciprocals of the fraction, 2 by 7, 3 cancellation, 2 value, and again this value multiplying with the 2, 4 2s are 8. Now this is the solution for that 12th one. And next 13th what given Sima here? Integral x cube minus x square plus x minus 1 by x minus 1 into dx. My previous 11th and 12th also denominator some value given, then we split that integration. But here every term if you split this term x cube by x minus 1 means difficult. So first we search any cancellation possible or any simplification there means, then we search that in simplification. So now we take here integral x cube x square, then first I take the value x square common, possible, then this value what, x minus 1 plus here x minus 1 divides, how much there here, x minus 1, and here x minus 1, overall x minus 1 common if you taken means, then what would happen here, x minus 1 into this value x square, here total if you taken means plus 1 divides this value again x minus 1 into dx, x minus 1 cancellation, x square their integration what would happen here, x cube by 3, 1 integration x plus c value, x cube by 3 plus x plus c. So that is the solution. Here first we take the value x square common, x minus 1, overall x minus 1, x square plus 1 value. So after then if you simplify and we applying the integration, integral of x square, x cube by 3, integral of 1, x plus c. So this is the solution of that 13th question. Right, next 14th Sima. So 14th. So here integral of 1 minus x into root x dx, multiple integral of 1 minus x into root x. So this one how to find it means integral of 1 minus x into root x, that is equal to, first we multiplying with the root x, 1 into root x minus x into root x dx value. Next what we run this value, integral of this value x power 1 by 2 minus, already here 1 there, 1 by 2, 1 by 2 plus 1, x power 3 by 2 into dx value. Now we are applying the integration. X power 1 by 2 means x power 3 by 2 divides 3 by 2 minus this value plus 1. 3 by 2 plus 1 means 5 by 2. X power 5 by 2 divides 5 by 2 plus c value. That is equal to 2 by 3 into x power 3 by 2. So 2 by 5 into x power 5 by 2 plus c value. Okay na? So that is the solution. Just we multiplying with the root x and x into root x 3 by 2, then we are applying the integration plus 1, 3 by 2 and 5 by 2 value, denominator and reciprocal of this conditions. Next 15th Sima, 15th one. So 15th what given here, same this type of model only given integral of root x into 3x square plus 2x plus 3 into dx. So integral of root x into 3x square plus 2x plus 3 into dx value. Then what we done here, that is equal to integral of every term we multiplying with the root x value. Then what we done Sima here, 3 into root x into root x plus 2 into x into root x plus 3 into root x into dx value, that is equal to 3 into integral of here x right, Sima here. So first 3 is the multiple and integral x square into root x. Root x means what? X power 1 by 2. So 2 plus 1 by 2. 2 plus 1 by 2 means 2 2s are 4, 4 plus 1, 5 by 2. So this one x power 5 by 2, x power 5 by 2 value, and dx, this value how much here? Dx plus integral of 2 into integral of here 1 by 2, 1 plus 1 by 2, 3 by 2, x power 3 by 2 into dx value plus 3 into integral root x means value what? X power 1 by 2 dx value. Now finally what we done here, that is equal to 3 into x power 5 by 2, 5 by 2 plus 1, 7 by 2, x power 7 by 2 divides 7 by 2. Okay, next plus 2 into x power 3 by 2, 3 by 2 plus 1, 5 by 2, x power 5 by 2 divides 5 by 2 plus 3 into x power 1 by 2 plus 1, 3 by 2, x power 3 by 2 divides 3 by 2 plus c value, plus c. Okay na? Now if you add powers 1, 5 by 2 plus 1, 7 by 2, 3 by 2 plus 1, 5 by 2, next 1 by 2 plus 1, 3 by 2. Now what we done here, 3 2s are 6, 6 by 7 into x power 7 by 2 plus 2 2s are 4, 4 by 5 into x power 5 by 2 plus 3 3 cancellation, and we take reciprocal 2 into x power 3 by 2 plus c value. Now that is the solution of this 15th question. Okay na? Right, next 16th one, Sima. 16th what given there? So 16th integral of 2x minus 3 into cos x plus e power x dx, e power x dx. Simple question only ma. Here 3 terms given, every term integration we are applying this separately. So then what we done here, integration means that is equal to 2 into integral of x dx minus 3 into integral of cos x dx plus integral of e power x dx value, e power x dx. Then if you run this value, 2 into x derivative integration x square by 2 minus 3 into cos x integration, integral of cos x sin x. Then what we run here, sin x plus e power x plus c. So that is the solution of this 16th question. And next 17th, Sima, 17th. So 17th integral of 2x square minus 3 sin x plus 5 into root x dx. 5 into root x dx. Both same only. Here 3 terms there, here 3 terms there. Now we separate the integration, that is equal to integral 2 into integral of x square dx minus 3 into integral of sin x dx plus 5 into integral of root x. Root x is nothing but 1 by 2 dx value. So that is equal to what we done here? That is equal to 2 into x cube by 3. Okay na, minus 3 into integral of sin x minus cos x plus this value cos x plus 5 into x power 3 by 2 divides 3 by 2 plus c value. Then if you run this value, that is equal to 2 by 3 into x cube plus 3 into cos x plus 10 by 3 into x power 3 by 2 plus c. Okay na? So that is the solution of the 17th question. And 18th, this is important, 1 mark question previous, 18th one, 1 mark previous question, and one example also there, this type of one question. So integral of 18th bit integral of secant x into secant x plus tan x into dx. So integral of secant x into secant x plus tan x dx value. Okay na? Now here see how to simplifying this one. So first we multiplying with the secant x plus tan x, secant x into secant x, secant square x dx plus integral secant x into tan x, secant x into tan x dx. My integral of secant square x dx, standard formula there, tan x plus integral of secant x tan x is equal to secant x plus sec. Okay na? Next 19th. So 19th, integral of secant square x divides cosecant square x dx. Then how to simplifying this one? Here secant given, cosecant given. So just we converted that secant and cosecant. That is equal to sigma integral of secant square if you taken out to the reciprocal means cos square. Cosecant if you taken out to the numerator, then what will on this value? Sin square x by cos square x dx. So cosecant, secant reciprocal cos, cosecant reciprocal sin, sin square by cos square is equal to tan square value, tan square x dx. Okay na? But tan square x formula there, so integration standard formula there, but secant there. So that's why this one if we converted, how do we convert? Identity there, secant square theta minus tan square theta is equal to 1. Then secant square, tan square theta is equal to what we have done here? Secant square x minus 1 into dx. Now already if you know that the integral of secant square x dx is equal to tan x minus 1 plus 6. Okay na? So that is the 19th bit. Next 20. So 20 what given here? Integral integral 2 minus 3 sin x by cos square x dx, cos square x dx. Okay na? Now if you want to simplifying this integration, here denominator given, first we separate the denominator, integral, this one what we done here, 2 by cos square x dx minus 3 into integral sin x by cos square x dx value. Then see here, that is equal to, if you done here, 2 constant, 2 into 1 by cos square x, 1 by cos square x is equal to secant square x dx minus 3 into integral sin by cos is equal to tan x into 1 by cos means secant x dx value. That is equal to sigma, that is equal to 2 into secant square x is equal to tan x, secant square x is equal to tan x minus 3 into secant x plus c value, secant x plus c. Okay na? So these are the 20 questions 7.1 and 2 objective bits given. The antiderivative of root x plus 1 by x is equal to given. Here just what we find out, antiderivative of this value given means, then what we written here, 21 bit if we find out integral of root x plus 1 by root x into dx given. So 21 bit the antiderivative of given. So that's why if you separate the integration, then what we done here, integral x power 1 by 2 plus x power minus 1 by 2 into dx value. Then already if you know that x power 1 by 2 means what we have done, x power 3 by 2 divides 3 by 2. X power n formula, integral x power n dx is equal to x power n plus 1 by n. Same here also, x power minus 1 by 2 means plus 1 by 2 divides 1 by 2 plus c value. That is equal to finally 2 by 3 into x power 3 by 2 plus 2 into x power 1 by 2 or root x plus 3. In the given options, 2 into x power 1 by 2. So third option correct. Third option, here 4 options given. In that 4 options, third option correct. This answer is C option. Option C. Option C is correct. Next last question in that exercise, 21 exercise, last question given. So which one given means 22nd question. So last one. So what given? This is also objective type question. D by dx of if d by dx of f of x is equal to 4 into x cube minus 3 by x power 4, 3 by x power 4, such that f of 2 is equal to 0, then f of x is equal to, here what given Sima? If d by dx of f of x is equal to 4x cube minus 3 by x power 4, such that f of 2 is equal to 0, then f of x is equal to, my question, 4x cube minus 3 by x power 4. Okay, now already starting we discussed this one, d by dx of f of x is equal to, this is the antiderivative, f of x is the antiderivative of this function. So that's why what we run here, the antiderivative of 4x cube minus 3 by x power 4 is f of x. Okay, na? So the antiderivative of this value is equal to f of x. So that's why what we run here, f of x is equal to integral 4x cube minus 3 by x power 4 into dx value. Now this is f of x is the antiderivative of this value. So antiderivative of this function is equal to f of x. Now we are applying the original function, if you want, means f of x, if you want, means we are applying the integration on derived function. Then what we run here, 4 into x power 4 by 4 minus 3 into, this one actually x power minus 4, x power minus 4 means what, x power minus 3 divides minus 3 plus c, here 3 cancellation, the 4 cancellation, x power 4 minus into minus plus 1 by x cube plus c. So this value is equal to how much more, f of x. Now this is equation 1 rather. Okay, na? Now if you put x is equal to 2 here, then see put x is equal to 2. Now this value how much here, f of 2, this value how much more, f of 2 is equal to 2 power 4 1 by 2 cube plus c value. Then 2 power 4 means 16, 1 by 2 cube means 8, LCM if you take 16 8s are 128 plus 1, 129 by 8 plus c. But given that what given here, from the given data, f of 2 is equal to 0 given. Next 129 by 8 plus c is equal to 0, c is equal to minus 129 by 8. From equation 1, what we done here, f of x is equal to x power 4 plus 1 by x cube minus 129 by 8 plus, so sorry, c value only that one, so 129 by 8. So here given options, which option means my x power 4 plus 1 by x cube minus 129 by 8. So option, so 1 is correct. So option A. Option A. Right. So first exercise over 22 portions. So in that indefinite integrals only, another concept here, methods of integration. Next concept methods of integration. So methods of integration. Here 3 methods there ma. Integration by substitution. So integration by substitution method. Integration by partial fractions. Next, integration by parts. Okay na? So next concept, methods of integration, integration by substitution, integration by partial fraction, integration by parts. So these are the three different concepts. Now first we learn integration by substitution method. Integration by substitution method. Okay na? So integration by substitution method. So integration by substitution method means what? Here if you substitute the proper substitution in the given questions, okay na? So integration by substitution method, the given integral integral f of x dx can be transformed So the given integral can be transformed into another form, by substitute x is equal to g of t. Okay na? Now here we take the substitution x is equal to g of t. The given integral, this is the integral, can be transformed into another form by substituting x is equal to g of t. Now here what given substitution, x is equal to g of t. So on that substitution we are applying the differentiation with respect to x. Differentiate with respect to x. Then what we done here? Differentiate with respect to t. So that's why dx by dt is equal to g of t. And again what we done here? Dx is equal to g of t into dt. Now if we take this substitution, then how to run here? Let we take the given integral. If we run like this, let I is equal to integral f of x dx. Now here we substitute the value, integral f of x is equal to g of t, f of g of t into dx is equal to how much there ma? G dash of t into dt, g of t into dt. So any integral value, if we convert it into substitution method, transform it into another form, then if we take some proper substitution in the given question, depends on that question, then we take here now x is equal to dt, we are applying the differentiation on both sides. Then if we find out dx value, the dx and x value we are substituting in the given function. Then finally if we get the another form, then we are applying the integration on the another form. So that process is said to be integration by. So right Sima, so this is the integration by substitution method. Okay, now any one integral value given, that value we convert into another form, then if we take suitable substitution in the given related question. Now here if we take x is equal to g of t, then we are applying the derivative on that function. After then these values are substituting in the given integral. After then if we find out the another form of integral, then we applying the standard formulas of the integral value, then we simplifying the given condition. So this process is said to be integration by substitution method. This process is said to be integration by substitution method. Okay na? Now if we take some examples and we simplifying the given integral by substitution method, then easily we understood that process. Now easily we understood that process. Sima, here on 4 examples given. So integrate the following functions with respect to x given. Integrate the following functions with respect to x given. So first question given sin mx given. Sin mx. And second question given 2x into sin of x square plus 1. Next third one given tan power 4 root x into secant square of root x by root x given. Next fourth one sin of tan inverse x, sin of tan inverse x by 1 plus x square. Now if you want to find out integrate, if you want to find out the integrate if you integrate these 4 questions with respect to x by substitution method, by which method ma? Substitution method. But in particularly questions like that not given ma in exams, just we find out the integration of the given function. Here only we explain that substitution method. Then if you take that is a suitable substitution or general method, then we applying, that is depends on your own work. Okay na? So right here see ma, sin mx. So first one what given, now if you want to find out integral of sin mx into dx, this one directly also if you done no problem, but substitution method means if we consider mx is equal to t, here what we taken ma, let mx is equal to t. Now we applying the differentiation on this function, then what we done with respect to, so differentiate with respect to x, differentiate with respect to x, then what we done here, m is equal to m constant, m into differentiate with respect to x value, then m into x derivative 1, then what we done here, dt by dx value, then m into dx is equal to dt, m into dx is equal to dt value, or dx is equal to dt radon. From this what we done here, dx is equal to dt by m, then integral what given here, integral sin mx dx is equal to integral sin mx, so sin this value t into dx is equal to what ma, dt by m value, that is equal to 1 by m into sin t integration what here, minus cos t plus t value, c value, that is equal to minus cos of t is equal to how much here, minus cos mx by m plus c. So starting I consider one problem, antiderivative of sin 2x, there if you run integral of sin 2x dx is equal to what we done, minus cos 2x by 2. So why you done by 2 means, this is the reason, when if you take substitution, that multiple must and should be if you done denominator. So this process is the substitution method, okay na. If possible, if you want to substitute means substitute, otherwise directly also done integration, no problem. Next another problem what given here, 2x into sin of x square plus 1 given, 2x into sin of x square plus 1 value. So second one integral, second one what given here, integral this value 2x into sin of x square plus 1 into dx value. So 2x into sin of x square plus 1 into dx. Here substitution means what we done means, let x square plus 1 is equal to t value, let x square plus 1 is equal to t. Next differentiating with respect to x, then what we run on this value, 2x dx is equal to dt value, 2x dx is equal to dt value. Next if you want only dx or 2x dx there now if we take this integral 2x into sin of x square plus 1 into dx is equal to integral, here see ma, 2x dx, instead of 2x dx is equal to what we done, dt value. Next sin of x square plus 1, x square plus 1 is equal to t value, then if you run the value here, sin t into this value how much, dt. Next again integral of sin t is equal to what ma, minus cos t plus c value. So t is equal to this value what we done here, minus cos of this value what we done here, x square plus 1 plus c value. So that is the integral of that given function, minus cos of x square plus 1 in plus c value. Okay na? So this is the substitution, 2x dx is equal to dt with respect to x, and we substituted 2x dx place, so this value, after that we are simplifying this condition. Next another question what given, Sima, third question given. So here third one what given here, integral tan power 4 root x into secant square root x by root x into dx value. Now if we take the substitution here, let tan root x is equal to t, differentiating with respect to x. So tan x derivative what ma? Tan x derivative secant square x into again d by dx of root x, is equal to 1 by 2 into root x into dx is equal to dt written. Now here secant square root x dx by root x there. So that's why what we done finally here. So from this step secant square root x by root x into dx is equal to 2 into dt. 2 into dt. Now these values are substituting in the given integral. Integral tan power 4 root x into secant square of root x by root x into dx value, that is equal to secant square root x by root x dx is equal to 2 into dt. So tan root x is equal to 4. So integral of tan power t power 4. So t power 4, these total value what we done, 2 into dt. 2 into dt, then integration 2 into integral t power 4. So integral t power 4 means what we have done, t power 5 by 5 plus c value, that is equal 2 by 5 into t is equal to tan root x, tan power 5 root x plus c value. Okay na? So this is the substitution, and this is also previous question, and this is the method. And the last one what given, Sima? Last fourth question what given? Sine of tan inverse of 1 by tan inverse of by 1 plus x square value. Then if we find out the integral, so integral of this value what we have done here, sine of tan inverse x, sine of tan inverse x by 1 plus x square into dx. Here suitable substitution means what? Tan inverse x. Let tan inverse x is equal to t. So tan inverse x derivative with respect to x. What we have done here? 1 by 1 plus x square into dx is equal to dt. Now above substitution if you have done means integral sine of tan inverse x by 1 plus x square into dx integral. So 1 by 1 plus x square dx is equal to dt. Then if you run the substitution here, this value again sin t into dt. Sin t integration what? Minus cos t plus c. T is equal to tan inverse of t. That is equal to cos of, this one what we run here, tan inverse of x plus c value. So this is the substitution method. Okay na? Substitution method if you solve these 4 questions. Is 4 questions. So next one 4 formulas there must standard formulas. Then if we learn prove that 4 formulas, integral formulas, after then we discuss the exercise 2. Just now explain that 4 formulas, standard formulas. So first one integral of tan x dx. First formula. Standard formula only that one note. So note, if you remember, integral of tan x dx is equal to log of secant x plus c. So log of secant x plus c value. Log of secant x plus c. Then how to find it? This one means so if we take solution, then integral of tan x dx is equal to integral of, first if you write on this value, sin x by cos x into dx. Okay na? Now if we take substitution here, let cos x is equal to t. So cos x is equal to t, differentiating with respect to x. Then what we done here, minus sin x dx is equal to dt value. Minus sin x dx is equal to what? Dt value. Then sin x dx is equal to minus dt. Now above if you substituted this value, integral minus sin x dx is equal to minus dt by this value how much here? Cos x. Oh sorry, cos x means here value how much here? T value. So minus dt by t. So already if you know that formula, integral 1 by x dx is equal to log of mod x. So that's why what we done here, log of mod t minus plus c value. Okay na? Now this value is equal to minus log of t is equal to how much there here? Cos x plus t. So minus if you take on to the m into log n, m power n formula, then if you run this value what we run finally log of cos inverse of x. So cos inverse of x means 1 by cos x. This one what we run 1 by cos x. 1 by cos x is nothing but this value if you run here 1 by cos x plus c. So 1 by cos x is nothing but secant x. So log of mod of secant x plus c value. Okay na? So here we applying the formula what ma here, m into log n is equal to log m power n value, log m power n. Then integral of, finally formula what ma here, integral of tan x dx is equal to log of secant x plus c. So this is also one standard formula. In case 2 marks question given means if you write this proof. Okay na? Right. Similarly integral cot x dx. So similarly second bit ma integral cot x dx is equal to log of sin x plus c, log of sin x plus c. Then here also if you want to solve this one, so integral cot x dx is equal to integral cot, then what we run here, cos x by sin x dx. Here substitution what we run, again let sin x is equal to t, then if you run derivative cos x dx is equal to dt value, that is equal to integral cos x dx is equal to dt by t value. Then what we run finally here, log of t plus c, that is equal to how much ma, log of t is nothing but sin x, so log of sin x plus c value, that is the cot integral value and the tan integral value. So next one, third one, log of secant x. So third one, log of secant x value. Right, Sima, third one, if we take here integral secant x dx is equal to log of secant x plus tan x plus c. So integral of secant x dx is equal to what ma, log of secant x plus tan x plus c value. Now see ma, how to prove that this value, integral of secant x dx is equal to integral of secant x, but if you multiplying numerator and denominator one term, that term is secant x plus tan x divides, here what we done here, secant x plus tan x into dx. If you take that value, numerator and denominator multiplying with secant x plus tan x. Now if we take the substitution, let secant x plus tan x is equal to t. Now differentiate with respect to x. Secant x derivative what ma? Secant x into tan x. Tan x derivative what ma? Secant square x into dx is equal to dt. Now if we take secant x common here, secant x common if you take it means what we done first, secant x plus tan x if you done into dx, that is equal to how much ma? Dt value. Now this is the numerator value, that is equal to what we done here, integral secant x tan x dx is equal to dt by, so secant x plus tan x is equal to t. So that is equal to again log of t plus c, that is equal to log of t is nothing but secant x plus tan x. So this is the another formula, standard formula of integral of secant x dx is equal to log of secant x plus tan x plus c value. And last one, another formula there, so that formula, so integral of cosecant x dx is equal to log of mod cosecant x minus cot x plus c value, cot x plus c. Okay na? Now this is also same standard formula. Then how to prove that this solution if you want means, then integral of cosecant x dx is equal to integral of cosecant x into cosecant x plus cot x. Here also if you multiplying and divisible with this value, cosecant x plus cot x into dx. Now if we take the substitution, then what we done here, let cosecant x plus cot x is equal to t value. Then if you run cosecant x integration derivative, what we done, minus cosecant x into cot x minus this value cosecant square x into dx is equal to dt. Next, minus cosecant x, if you take common, then what put on this value? Cot x plus this value cosecant x dx is equal to dt value. Now numerator sima cosecant x plus cot x up to this one minus dt. So that is equal to what we substituted here, numerator minus dt by t value, minus dt by t value. Now if you substitute the value minus dt by t means what put on here, minus log t plus c value, that is equal to minus log of t is equal to what here, cosecant x plus cot x, cosecant x plus cot x plus c. Actually this one there. Now if you multiplying again, if you simplifying this value, actually what my formula, cosecant x minus cot x if you want means, here if you multiplying numerator and denominator, cosecant x minus cot x, then how do we convert this value? So numerator is become as cosecant square x minus cot square x divides this value cosecant x minus cot x plus c. Actually here what operating, so numerator and denominator multiplying with cosecant x minus cot x, a plus b into a minus b, a square minus b square, denominator cosecant x minus cot x. So already identity there, cosecant square theta minus cot square theta is equal to 1 value. So that is equal to minus log of 1 by this one, what we done here, cosecant x minus cot x plus c. Now reciprocal if you taken means what we done here, minus log of this one cosecant x minus cos x whole inverse 1 plus c, log m power n, if you taken minus minus become as a plus. Finally if you write on the value log of this value cosecant x minus cot x plus c. So these are the 4 important derivatives and standard formulas for in integration. Okay na? So now once again if you revise that 4 derivatives what we written or what we proved, that 4 formulas. Once again we revise that 4 formulas. So first one what we proved that there here, integral of, first one what integral of tan x dx is equal to log of secant x plus c, and second one what integral of cot x dx is equal to log of sin x plus c. So third one what integral of secant x dx is equal to log of secant x plus tan x plus c. Next fourth one, integral of this value cosecant x dx is equal to log of cosecant x minus cot x plus c. So these are the 4 standard formulas in integration with the proofs also explained. So these related questions, next exercise there 7.2 totally substitution method problems there. There also 1 marks and 2 marks questions are important in that exercise.